Good evening to Encik Nur Halim bin Asim. My name is Suryan Al-Girajamuan and my teammate Nur Ainatika binti Muhammad Nur Aisha binti Nur Razmi. We're going to present about Lab 5 path loss model analysis. So for the objective, we're able to write a MATLAB program for the path loss analysis and to able to determine the free space loss and the power received. The equipment we use is MATLAB software. So let's continue with my teammate Aisha.
Okay, for the procedure, by using the MATLAB software, we write the program as shown below. So we insert the data information has a table 4.2. So for the step 1, 3 and 5, we use the same variable, which is the frequency is 1000 MHz, distance 100 km, GT 5, GR 7, PT 10, and then the result is the path loss we get 132, Rx power in dB is negative 110, Rx power is 9.03 picowatt. So for the step 2, we use the frequency 2000 MHz and distance GT, GR and PT, we use the same variable as the number 1. So the result for the path loss, we get 138, Rx power is negative 160, and then the Rx power in watt is 2.26 picowatt. So for the number 4, we use distance 250 and then the frequency we use 1000, GT 5, GR 7 and PT is 10. So for the result is path loss we get 140, Rx power we get negative 180 and Rx power in watt is 1.45 picowatt. And then the last one is for the step 6. We use the frequency in 1000 MHz, distance 100, GT 5, GR 7, and we change the PT to the 20. So for the path loss, we get 132. Rx power is negative 100. Rx power for the watt is 90.3 picowatt. So we calculate in the manual. So the value of the MATLAB and calculation is quite same. So the next is the question.
Okay, thank you. For the question, there are 3 questions here. So for the first one, comparison of step 1 and 2. What happened to the output when you modify the frequency value? So when we increase the frequency value from 1000 MHz to 2000 MHz, the wavelength also increases. Besides that, the path loss and received power also will be increasing. For the second question, comparison of step 3 and 4, what happened to the output when you modify the distance value? When the distance value is increased from 100 km to 200 km, the path loss and the received power in dB also increases. The third question is comparison of step 3, step 5 and step 6. What happened to the output when you modify the power transmitter value? When the power transmitter value is increased from 10 dB to 20 dB, the value of path loss and receive power in dB are same, but receive power in watts will be increasing. Next, number 2, for step 1, calculated using theory, compare your test result to the MATLAB, give your comment. So the calculated value from the MATLAB and the manual calculation are the same. This shows the simulation and calculation are correct. So next will be continued by Ainatika.
Okay, for the discussion, path loss analysis has been carried. So path loss is an important component in design of the link budget in telecommunication system. Besides, path loss delineates a decline in power density of any given electromagnetic wave as it propagates through space. Furthermore, the analysis of the path loss has been carried and proved by using the MATLAB software as shown in the result. So from this lab, we able to know that the higher the frequency, the greater the path loss. So the path loss may be due to many effects such as free space optic loss, the distance between transmitter and the receiver. Next, for the conclusions, at the end of this lab, we able to write a program using MATLAB software for the path loss analysis. Besides, we able to determine the free space loss and the power received. We also able to understand the theory of free space path loss. And lastly, we able to make a comparison between the results from the MATLAB software and the theory calculation. That's all from us. Thank you.